So here's a simulator we're going to use to simulate drawing orange candies. Now with the probabilities already set at 0.5, we want to have the number of candies be at 30. So I'm going to take 30 candies from our sample, and let's go ahead and change this to the proportion of orange rather than the number of orange. And I'm going to select Draw Sample. And we see that it's going to animate this, and we can see all the oranges going into one, anything that's not an orange going into the other, and we get a sample proportion of 0.467. And this is plotted on the graph. Now let's do another one. So I draw another sample, and this time the sample of oranges I get 0.5. So 50% of my Reese's Pieces, my candies I selected, are orange. And this dot is shown in the graph as well. Let's take one more sample. I end up getting a sample proportion of 0.333. And we can see it's plotted as well on the graph. Now I'm going to unselect Animate. And let's do this several times. I want to have a total of 1,000 different samples here. So I'm going to put 997. We've already taken 3. So to get to 1,000, we'll do that. And click Draw Samples. The dot plot shows the result. Isn't that amazing? How would you describe this shape? So the distribution of p hats is normally distributed with a center of about 0.5. The center is clustered around 0.5. Was probably not a big surprise. We knew that the population proportion of orange candies was p equals 0.5. So this example is illustrating something very, very important. In general, we take samples in order to estimate the population proportion when we don't know the population proportion. So I'm going to go ahead and select Summary Statistics here. We have a mean. The mean of the 1,000 samples we took was 0.501. Again, we note that the dot plot displayed that approximated the sampling distribution was indeed very close to this population proportion of oranges, p equals 0.5, giving us a p hat of about 0.501. Because this happens with a sufficient sample size, p hat is called an unbiased estimator of p. That is, we can rely on p hat, the sample proportion, for giving us a very good estimate for p, the population proportion. P hat neither overestimates nor underestimates that true population proportion p. So we're going to talk more about biased and unbiased estimators in a later lesson. Let's return to the Reese's Pieces applet and let's simulate the sampling distribution for the proportion of orange candies when n equals 30. Let's set the number of samples to 500 and be sure that the summary stats is on. And we're going to note the mean and standard deviation. Also, make a note of the spread. So I'm going to reset the applet here, and let's change the number of samples to 500. So for my simulation, if you're following along with me and you're actually doing the simulation, yours is going to be slightly different. I get a mean of about 0.494 and a standard deviation of about 0.088, with the values ranging from about 0.25 to about 0.75 or 76. Now we're going to make one change. Let's double the number of candies in the sample to 60. And what do you notice? The mean is roughly the same. So my mean here is 0.502, pretty close to what we had when we had an n of 30. But what about my standard deviation? The standard deviation is significantly less, at about 0.062. So also notice that my values range from about 0.3 to about 0.68. Looks like we have one outlier here at about 0.74. So there's less variability for large sample sizes. So if you're able to, click on the Show Previous button and you'll see the previous distribution in a light gray. I really recommend that you play around with this applet, so increase the number of candies as well as some of the other values to see their effect on the center shape and spread of the distribution. So now change the probability of orange to 0.1 and the number of candies to 10. and the number of samples to 100. Select Draw Sample. Select Draw Sample, and what do you notice about its shape? It is not normally distributed, is it? It is skewed to the right. Now, let's just change the probability of orange back to 0.5. And we're going to press Reset. And click Draw Sample. What do you notice? It is back to our familiar normal and symmetric distribution. Now let's change the probability back to 0.1, but this time we're going to increase the number of candies to 20. What do you notice? It's getting close to looking more normally distributed and symmetric. Now increase the number of candies to 50, and what do you notice? It is getting closer to looking more normally distributed and symmetric.